Okay, so here I'm back again, and this is the fourth video in a series of 4. And in this unit, we're covering correlation, least square regression. So in the first video I did was correlation. It was kind of long, okay, on the long side. Then I did a short video on meaningfulness, or what percentage of variance is accounted for in the y variable by the x variable, okay? And then we did, in the other short video I did right before this, was the least square regression line. And in the least square regression line, what we're trying to do is fit a line to our data that will give us the shortest distance to the farthest reaches of our data. So if this is our data, oops, let's just draw a circle around it, Heidi. And we're lassoing that data, just like we did when we played on the Rossman chance applet this week, right? So if I lasso that data, okay, I want to draw a line so I get the shortest distance between the outer reaches, okay? So the next thing I need to do is I want to calculate what that distance is, or how do I account for that data. So just like we did with mean and standard deviation, okay, we get a mean, okay, and this is the average of everything that we've done, okay, average of all the scores. And then we had the standard deviation. The standard deviation was the average distance to the mean, okay? That's the average distance to the mean. Works the same way, surprisingly, with our line, our prediction line. So if this is our y predicted line, okay, over here, my least square regression line, okay, if I know that, oh, let's see, we'll pick somebody. Maria, let's say Maria studies for 3 hours, and I'm going to predict Maria's score. Okay, and that's going to be somewhere 78. Let's call it 78 on my prediction line. But I'm predicting to a point on the line, and we know probably she isn't going to score exactly that because it isn't a perfect relationship. It has variance. So we're going to look and we're going to say, how do I figure out how to do the plus or minus on Maria's score? So I want you to think kind of creatively here, because I can't draw. We've talked about this, okay? So I know, okay, I'm going to do it in black, okay? I know that it's going to predict onto that line, right? But I need to know what the range is here. And how sure am I that this is going to be what she does? So think about putting, and I'm going to do it in green. I know you can't, well, I'll do it in red. So think about putting your normal curve, oh, I'm so bad at this, on the line like so. Okay, where, oh, it's really terrible, Heidi. Start again. Okay, start again. Okay. That's not much better, but we're going to call it a day. Okay. Where the mean is going to fit somewhere on that line. Okay, so all I've done is flipped my normal curve from the horizontal, and I rotated it, in this case, 90 degrees counterclockwise. I rotated it, and I've put it on the y-axis. So I want to see if this is going to be the y predicted, okay, the middle. I want to know, when would I be 95% sure that I'm including Maria's score? What's the variation in the data? Okay, so in order to calculate that, I have a number of ways to do it. Okay, so the first way that I can do it is with S. And S relies on the residual plots. Okay. Residuals are simply the score minus the y predicted. Okay, so it's the y predicted minus y. So things that are above, is it right? No, it's the other way around. Let's do it this way. Ah, perfect, perfect. So the score I predict on y, okay, or the actual y that I have in my data, and I'm going to subtract the y predicted, and that'll give me the distance between any of these points and the line. When I do that, some of the dots, right, some of the points are going to fall below 0. And some are going to be above 0. Okay? So all I've done is take this and rotated the y predicted onto an axis, okay, a horizontal axis, and called this 0. Whereas when there's no difference between these two things, I've predicted perfectly. Okay? Where most of the time I'm going to have something called a residual. The residual is always the leftover. Okay? So these are, I'm a little bit high, I'm a little bit low, I'm just in the range. You can calculate the average or the standard, the average distance to the line, the y predicted, okay, and it is written on computer programs as S, okay. It's something I don't see people do by hand very often, and it's not something I necessarily want you to be able to do in my regular statistics. You actually, in AP statistics, it comes out on your calculator, so there's no need for this, okay. So I'm going to get rid of this. And I'm going to teach you a different way where it's still that same concept of the standard deviation, or S, but it's called SEE. The standard error of estimate. How much am I error? How much error is in this equation? Okay, so it's the standard, okay, the average, standard, what's usual, okay, error, and I'm going to estimate it. So the standard error of estimate is simply the standard deviation of y times the square root of 1 minus r squared. So if we know that, we were doing that example in our last video where r is equal to 0.8. Then we have r squared is equal to 0.64. Okay. Let's say the standard deviation of y is equal to 10. Okay. So I would take SEE, and it would be equal to 10 times 1 minus 0.64. Because r squared is 64. Don't square it again. Okay, square it once, be done with it. So this is 10 times the square root of 0.36. Good? Okay, what's the square root of 0.36? 0.6. Say 0.6. 0.6! 0.6 times 10, that's 6. Correct? So I have, this is equal to 0.6 times 10 is equal to 6. Okay, so for every hour of study, I expect there to be this range here in the score. So my range is 6. Okay, so I would say if you studied 3 hours, okay, so Maria studies 3 hours, and her y predicted, let's say, is, what do we say, 78, okay, her y predicted is equal to 78. We can actually calculate this, but, I'm guessing here. I'm pretty good at guessing. Okay? And I say the SEE is 6. Okay? So I have y predicted equals 78, and I would do plus or minus, correct? Plus or minus. Now here comes the tricky part. We're going to multiply, we're going to put a 2 in there. And the reason we put a 2 in there is because remember, if I want to be 95% confident of something, that's not 1 standard deviation, that's 2 standard deviations. If I want to be 95% confident that if Maria studies this amount of time, she's going to get that grade, I need to have 2 standard deviations. If I did 1 standard deviation, that would only be 68%. I'd only be 68% sure. I want to be 95% sure. Pretty sure, okay? So I take 2 times the SEE, which is 6, okay? So I predict Maria will have a score of 78 plus or minus 12. Meaning that her grade is going to vary. If I subtract 12, I get 66. And if I add 12, I get 90. So I am 95% sure that Maria's going to score between 66 to 90. Lots of concepts in there. I know I went kind of fast on this one, okay? But this is something we've done. We just did it with 1 point to a mean. Here we're doing it to the y predicted, to the point on a line. So there's just a series of normal curves running in order for you to predict onto the line. So instead of the mean and the standard deviation, now we have y hat and the SEE. Excellent! Can't wait to see you this week. Okay? Have a great weekend and be safe. Bye!